Alright folks, I want to cover a few of these questions with you in regards to at least getting a picture set up. I suggest on this worksheet that you draw pictures. So I'm going to bounce around here a little bit. I think a lot of these are pretty self-explanatory. We haven't talked about this formula yet for a circle, but you should know these two. Remember, the area of a circle is pi times your radius squared, and circumference is equal to 2 times pi times your radius. To use those, obviously, number 1 here, number 4, if they show up any other place, obviously you can use them as you see fit. Number 7 says a parallelogram with sides 6 and 10 that form a 30-degree angle. Remember the area formula for a parallelogram. Area is equal to base times height. So if I've got a parallelogram that has a 30-degree angle in it, okay, if I draw it this way, this is 6, and this is probably 10. I'm going to make that 30 degrees. When I make that 30 degrees, I make that 30 degrees right here. Right here is my H. Okay, so then that should give me a triangle here that has got 6 is the hypotenuse, 30 degrees, 60 degrees. Okay, and you're gonna go through and use your 30, 60, 90 template to help you find what H is in that problem. A rectangle with a length of 12 inscribed in a circle with a radius of 7.5. So your circle is going to look like this. So here's our circle. Remember what it means to be inscribed. It means that the shape is going to be on the inside, and the geometric component has to be the fact that the vertices of that shape all touch the circle one time. So something like that. Okay, so that is inscribed. That's the inscribed rectangle. What's going to be interesting here is that the circle center is right there, which also ends up being the place where that diagonal and that diagonal intersect. So I kind of missed it, but let's see here. Well, there you go. So that point right there is the center of the circle, and it's essentially the intersection of the diagonals. Now, the key thing here then is to realize that that right there is a radius of your circle. Okay, if that's a radius of your circle, you now know that that's what, 7.5. Okay, you knew that this was 12 here. Okay, if we think about this triangle here, or it could be this top one, what we find out is if I draw that segment there, it can be perpendicular to that, and it can give me this distance from that point there to that point there to be 6. Remember, that's a point from the vertex of an isosceles triangle perpendicular to the base, splits the base in half. So it's a right triangle here. You know that the hypotenuse is 7.5. You know this here is 6. That should allow you to find that distance. And then think about what you can do with that distance to find that distance. And once you have that longer red distance, you have that 12, and figure out what you do with those two then to find the area of the rectangle. This next one here says find the area of a square with a perimeter of 32. So a lot of times as we get further into math, they start giving you information hidden inside or implicitly given in other formulas. So if the perimeter is 32, so the perimeter of a square is 4 times s. So here they're saying the perimeter then is what, 32? So I did it this way. 32 is my p, and I've got 4s. You can solve then for s. Okay, figure out what that is. And then once you have s, how does that allow you to find the area of a square? Find the area of a rectangle with a length of 4 and a diagonal of 6. So that's very similar to this circle question, just giving you different information without the circle. Number 4 down here says find the area of a rhombus with a side of 17. Remember, the definition of a rhombus is that all the sides are the same length. So if that's my rhombus, side of 17, 17, 17, 17. Okay. Remember, area of a rhombus is 1/2 diagonal 1 times diagonal 2. You know one diagonal is 30. So 1/2 of 30. Now I got to find the other diagonal. Well, the way we go about doing that, let's say this is 30. So that's the diagonal that we know. This is the diagonal that we don't know. You have to remember what those two diagonals do to one another. Okay. And that should tell you what that distance is there, which then will allow you to find that one. Okay, which is just that distance right there. And think about what you can do with that value to get the entire diagonal number 2. Question number 5. I will do with different numbers. I think it's a very unique question. It's an important question. So you have a parallelogram with sides of 8 and 12. So let's change that to get rid of those, get rid of this. Let's say sides of 10 and 14. The shorter altitude is, let's say, I don't know, 4. So we're looking at here, hopefully these numbers kind of work out. We've got a parallelogram here. And they're telling us we have a side of 10 and 14, so I'll make this my 14, this my 10. They're telling me the shorter altitude here is 4. They want to know what is the longer altitude. Well, the longer altitude would actually be kind of that solid red line. Okay, so what we're going to do in this problem is I'm going to find the area using the information they gave me. Well, if this is my shorter altitude, which is 4, remember altitude times the base is the area for a formula, or area formula for a parallelogram. So I'm going to go, what, 14 times 4. Okay, so that's going to give me, what, 56. 56 is the area of this thing. So now what they're trying to do is figure out, well, what is this h then here? Well, remember, if whatever that h is, that's the altitude, I have to use that as my base. Still finding the area of this parallelogram. And if I know the area of that parallelogram using one technique was 56, then it's got to be 56 using a second technique as well. So I know capital A is 56. I know the base that this H is being drawn to is that 10. So I know B is 10. And now I'm solving for H. That's what they're asking us to find. So I can divide both sides by 10. Get 5.6 is the second length, the second altitude length. So that's how you do question number 5. Obviously using different numbers over here. Special right triangle, 30, 60, 90 triangle. Perimeter, remember, add up all the side lengths. Going through, make sure you pay attention to the number of decimal places that I ask here. Okay, this is a special type of triangle, a 3, 4, 5 triangle. We've talked about that several times in the past. So remember what that is. Number 5, we talk about an equilateral triangle. Okay, so equilateral triangle. When we have an equilateral triangle, obviously here they're saying the side lengths are all 8, but think about an equilateral triangle. I'm allowed to do that. It takes this segment here. If it was 8 to begin with, it now becomes 4. And remember, if it was equilateral, that means that was 60 degrees, this is 90, that's 30. This is going to be your H, so figure out what that H is from the information given here. And then you figure out what that B is. Okay. Equilateral triangles are unique in the respect that you can come up with its own little formula. So if I have an equilateral triangle, let's say this is S, then that would have to be S, and that would have to be S. Okay. And if I draw down this thing here, that's actually going to take the S and it's going to split it in half. So that's S over 2. Remember, this is 60, this is 30. So in 30, 60, 90, this is my N. This would be my N radical 3 side. So if I'm trying to figure out area is 1/2 BH for my triangle, it's 1/2 B is that distance there, so it's S, and H is that distance there, so it's S radical 3 over 2. If I multiply this all out, I get 1 times S, which is S squared, times radical 3, all over 2 times 1 times 2, which is 4. So that's the area formula for an equilateral triangle based off of knowing S. S being a side length. Okay, so that's a specific formula. It's generated by using 1/2 BH, but it's specific then to equilateral triangles. I think these next ones are pretty self-explanatory. Obviously, you're going to want to kind of break that one up into 2 shapes. That makes that top triangle isosceles. This is an irregular shape. Actually, no, it's not. You can look at it as being irregular if you want to. Basically, make it 2 triangles and add them together. But if that's a right angle and that's a right angle, then you have alternate interior angles congruent. So these purple pink lines here are parallel. So this is a trapezoid. Okay. So the rest of these, I mean, this isosceles triangle, the base of 10, perimeter 36. So it gives you enough information. It's isosceles. You know that this is 10. So what do both of these have to be? Once you have those, then you can draw that segment down. Splits the 10. You have that number. You can use the Pythagorean theorem then to find h. Then use that with 1/2 BH. 13. So 12 is like the one above. What was it? Question number 5. So 12 is like 5. 13, you got your parallelogram again. But now they're saying you got side lengths of 6 and 10. So 6, 10. This is a 45-degree angle. So now to find h, you're going to use that 45, 45, 90. Let me tell you the perimeter of a rhombus. What do I need to do? What do I know about all the side lengths of a rhombus in order to find one side length given the perimeter? Number 19. You've got a square inscribed in a circle. So here's my circle. So a lot like the rectangle question. So let's see here. There's my square. Now we're going to say that the square has a radius of r. Or sorry, the circle has a radius of r. When the circle has a radius of r, there's a lot of different radii you can draw. And you can draw that one. You can draw that one. But neither of those, or maybe that one, you can draw an infinite number of them. But any of those green ones I just drew don't tell me anything about the square. Remember, that's what I'm trying to find the area for, a square. So let's draw a radius here that makes sense for the square. So that distance right there is the radius of the circle, which is r, but it's also something for a square. Okay? My suggestion to you, the next thing I would do is think about what that distance has to be. That has to be r as well. Then my question is, what does, because that's a diagonal now of a square, what does a diagonal of a square do to that angle? And once you figure that out, it should tell you what kind of triangle this is. And once you know what kind of triangle that is, obviously it's a right triangle, but it can be more specific. Knowing that the hypotenuse here is 2r, you should be able to find that side length and that side length. And either multiply them together or just square one of them to find the area then of that square. 20, much like the question up here, what was it, question 10. Okay. So let's go to the second worksheet here. All right, these are all very similar. Okay. Just walk you through some pointers on each one. Equilateral triangle. So equilateral, what's that mean about all the sides? And if you know what it means about all the sides, that should allow you with that 21 to find what 1s is. So I should tell you what s is. Okay. My suggestion then, area then, let's use the s squared radical 3 over 4 formula for the area of an equilateral triangle. Rhombus, perimeter of 52. So once you have your rhombus with a perimeter of 52, that should tell you what one side length is. So let's call that x. Okay. You know one diagonal is 10. So let's say that's 10. You should remember that the diagonals of a rhombus bisect each other. So that would be 5. Remember this x you know, but you don't know the dotted distance. You should be able to use the Pythagorean theorem to find that dotted distance there. And then when you double that, you should be able to find that one diagonal, which was given, was 10. And once you double the dotted distance, this dotted distance right there, you should get your second diagonal and then area is 1/2 d1 d2. This is similar to one on the last page. Number 4, find the area of a parallelogram. There was one on the last page similar to that. I just want you to leave your answers in simplest radical form. On the last page said you could, I believe it said around to 2 decimal places. Here I'm asking you to leave an exact value, so you're not using decimals here. Number 5, same thing. Okay. I'm going to draw that down. That's my H. Now this is so I've got a triangle here that's got a 52-degree angle on it. Now that's 52. Okay. I don't know that. But if that's 6, that's got to be 6 as well. So you're going to figure out which one of these you need to use, SOHCAHTOA, to find H. And once you find that, area is going to be B times H. Okay. Now, when you do this, because I asked you to leave your answer as an exact answer. So that means when you find whatever this is, sine of 52 or cosine of 52 or tangent 52, whatever one it is, do not use your calculator. So, for instance, if I'm going to area is B times H, let's say that B ended up being, B is our 13, and let's say that H ended up being, and I'll use completely different numbers here. Let's say it was 8 cosine of 52. When I go B times H, I'm going to go 8 times 13 times cosine 52. And now 8 and a 13 work together. So I'll multiply those together. So it's going to give me, what, 104 cosine 52. Remember, this is an irrational number. That's a rational number. I'm not going to multiply them together. So that would be the exact version. Rhombus, so when they say that the rhombus has an angle of 120, that means that entire angle is 120. Sides are 6. If that's 120, remember it's a parallelogram. That's what all rhombuses are. You should be able to, because the same side interior angles, tell me what that angle is, and then you can work with that information to figure out you're going to work essentially with one of these little triangles in here to help find D1 and D2. Questions number 7. The first thing here with 7 is you got to realize that that distance and that distance are the same. So this is an isosceles trapezoid. I'm going to drop that down. It's an altitude. That's H. I'm going to drop that down. Also H. And what happens here is that this shape in the middle becomes a rectangle. So if that's a rectangle and it's isosceles trapezoid, that triangle there and that triangle there are the same. They're congruent. So knowing that this is a rectangle and knowing that these two blue triangles are congruent, you should be able to find maybe that green distance or that green distance. Once you have that green distance, you also have that 5. This is a right triangle here. You have that 5, that green distance, and through the Pythagorean theorem, you should be able to find H. And then remember the area formula for a trapezoid is that. Over here, same approach. Now, the thing here is that this is a rectangle. These are both altitudes. Okay, so if that's a rectangle, you know then that you can take this 14 and this 37, do a little bit of work to give you that distance there. Now, if you have that distance, this is then a 45, 45, 90 triangle. Once you have that distance, you should automatically have that distance. Once you have that distance, it should be the same as that one. And now that gives you the ability to work with this 30, 60, 90 triangle to find that distance right there. Okay? And then when you go ahead and plug into your formula, let that be B1. This entire distance here will be B2. I'm going to argue, I'm not 100% sure, but I would venture to say that whatever that number there is, it's probably irrational. So let's say it ends up being 5 radical 3. It's probably not, but let's say that's what that distance right there is. And then I want that 37. That distance right there, I cannot combine those to one solid value. That's irrational, and this is rational, so we leave it alone. So that should help you with how you gotta leave your answer in simplest radical form. Give those a shot. If you got any questions about anything, don't hesitate to, again, send some questions via email, and I will get those back to you quickly.